How we get 99? Origin and start basically put new values into our location counter or change the value of the location counter. Now when you have origin a minus 1, it means that the location counter value should change. So what is the address associated with this symbol a? If you look at the symbol table, the address associated with a is 100. So when you say this is 100, 100 minus 1 is 99. So what happens to the location counter value? It becomes 99. For this assembler directive, I am not going to generate any intermediate code. Okay. So this particular statement will be at location 99. It has changed because we have encountered an origin statement in our assembly program. So for this particular label that we have encountered in our assembly program, I have to enter it if it is already not existing in our symbol table. It is there, okay, in a symbol table at location 4 we have symbol 4, okay. So what I do, I put the associated location counter value which is 99 and I will write the length as 1 because I have declared only one constant, okay. And for this I have to write an equivalent intermediate code, that is it is a declarative statement, okay. DC is 01 is the code associated with DC, okay. We don't have the first operand, it is a constant and it is 5, okay. Next we come to this statement. Before that it is incremented which becomes 100, okay. So when it becomes 100 we are incrementing by the length of this instruction. We have declared only one constant, so size is incremented by 1 or location counter value becomes 100. We have encountered the statement label B. So when you encounter B, you check the symbol table. If B is already there, if it is there, just associate the location counter value which is becoming 100, okay. What does this mean? It means that A and B refer to the same memory location. That is the meaning of it, and the length will be 1, okay. Okay, because I have declared only one particular constant, and for this I am going to write DL, 010. It is a constant and so it is 90, okay. Then I have encountered and I have to see whether any literals are present in my table, in my program. No literals are present, so I do not write an equivalent or I do not write an intermediate code for this particular statement, okay. Now what does this end L1 specify? L1 specifies that you have to, when the program is getting executed, this should start its execution from L1. Okay, this is nothing to do with the intermediate code or the equivalent machine code that would be generated. It simply specifies that execution of this program should start from the statement that is associated with the label L1. Now, how do I write the machine target code for this particular intermediate code generated? Okay, at location 100 we do not write anything, but from 103, yes, this is the instruction of code 4.1. It says refer to the symbol table, get the address associated with the symbol at third location. Symbol at third location happens to be 100, so it will be 100. For this I will write 104. The instruction opcode is 1. The first operand is 1. Refer to the symbol table. Get the symbol that is at location 4. At 4 we have C and its address is 99. I need 3 digits to represent this particular third operand, so it is 099. Then you have 105, this statement, okay. It is having an instruction opcode of 5. First one operand is 1. Refer the symbol table, get the address associated with the symbol at location 5, that is D in our case, and it is 101. Okay. Then you have 106. The instruction opcode is 10. There is no first operand. Refer to the symbol table and get the address associated with 5. The address associated with a symbol whose index value is 5 is 101. So it is 101. And then we have 99. Okay. You have 01. You have 0. It is a constant, so you have to write the constant like this as it is. and then you have 100. Again it is a constant defined, so 0 and 0, 1, 9, and then we have end and we stop processing over here. So this program basically is trying to make you understand how processing of EQU and origin statements are done, and what do you do with an end that is associated with an address specification. Now if a constant is written here, execution of that program should start from that constant. Otherwise, if an operand is written here, if a label symbol is written over here, you should begin the execution of that instruction that is associated with this particular label. So we've done 3 kinds of assembly programs, each containing different kinds of statements, and I try to cover all kinds of statements in our assembly program, and what is the intermediate code generated, and how do I get the equivalent machine program, how do I generate the associated tables, like whether it's a literal table or a symbol table or a pool tab, has been explained. This completes unit 1.